we're going to be looking at whether a copper wire of length L with a diameter of 2.5 millimeters can have the same electrical resistance as a tungsten wire of the same length, but not necessarily the same diameter. So the first thing I did was I looked up the resistivities of these two different metals. I got this from hyperphysics.com, and because we're going to need these later on. And so I found the resistivity of copper is 1.68 times 10 to the negative 8th ohm meters, and the resistivity of tungsten, W is the chemical symbol for tungsten, is equal to 5.6 times 10 to the negative 8th ohm meters. And so if I want the resistance of a piece of copper wire to be equal to the resistance of tungsten wire, I'm going to need to use this equation that relates the resistivity of an element to the length of that element times the area of a cross section of that element, which in this case, these cross sections are going to be circles because it's a wire. So if I want these two resistances to be the same, what I'm going to do is start with this resistivity, or this equation for resistance that involves resistivity, and make my way from there. So if I want the resistance of a slice of copper wire to equal the resistance of a length of tungsten wire, this is where I'll start. So I'll start making substitutions. So the resistivity of copper times a ratio of the length over the cross-sectional area. Notice that I'm using subscripts here for the resistivity and the cross-sectional area because these two numbers are going to be different for copper than they are for tungsten. However, for the length, since the condition is that their lengths have to be the same, that is why I'm not using a subscript there. And the benefit is that we can, because these two numbers are going to be the same, then algebraically they cancel out. And so what I'm also going to do is make a substitution for the cross-sectional areas here. So I'll have the resistivity of copper divided by, it's going to be pi, the radius of that copper squared, that's just the area of a circle, and then have the same thing over here. Okay, and again, doing a little bit more algebra, you can cross out pi on both sides. And so what I'm left with is a ratio of the metal's resistivity to its radius. And so remember, we're trying to find out if it's possible for a wire of these two different materials to have the same resistance if they have the same length. So what we're really doing is checking to see if it's possible for this equal sign to be valid. And in this case it is, and the only reason it's possible is because we're allowing for a different radius. And so if we did not have that condition, if the radii had to be the same, what we would get is this equation right here. And it's mathematically impossible to take two different numbers, divide them by the same number, and then have the result be equal. So it is in fact possible for these two wires to have the same resistance if they have different radii, and with the condition again of them having the same length. So now what I'm trying to figure out is, okay, well, what is the radius of that tungsten wire given the radius of a copper wire? So I'm going to solve for the radius of my tungsten wire, and that's going to be equal to the radius of the copper wire times the ratio of the resistivities. Okay? And if I go ahead and plug these numbers in, now we're given the diameter of the wire, but we need to make sure we're working with the radius, so it'd be half of that. I'm going to convert that to meters, so that's going to be 1 1/4 times 10 to the negative third meters. And then I've already pulled my resistivities, so I've got 5.6 times 10 to the negative 8 divided by 0.68 times 10 to the negative 8. And so what I get when I crunch those numbers is I'm going to get 2.28 millimeters. So the answer will be in meters, but I went ahead and converted that to millimeters since that's what we were originally working with. And so, yes, it is possible for a copper wire and a tungsten wire to have the same length and the same electrical resistance